Big hand.
Thank you so much for that. And I will just very quickly welcome you to introducing SCM to a young agile startup with Lars by DevOps Kone, and thank you to our generous host, Fukafe. I just have a few slides. Well, the presentation will start very, very soon. Later, as promised, we're going to have pizza and some drinks, although you can already have drinks. And there should be some time for questions, continued discussion afterwards. Very briefly, even when Fukafe really organizes everything, but if there is any topic that you'd like to talk about, and it at least touches on DevOps area, just reach out to us. You can talk to me later, or find us in a different places, and then we can help you set it up. And I have a very quick question, because we have a couple of channels, and I wonder like which one of these we should keep continuing. So who here found out about the event at meetup.com? Okay, that's the expensive one, that's good. Then are you aware of our LinkedIn group? A little bit. We have a GitHub, the repository, but I don't really know what's going on there. We have a Discord channel that we also are trying to kind of bring up to life. So I'm assuming you found out from Fukafe mostly? Yeah, okay, that makes sense. But yes, that's all I had to say. Now, please give a round of applause to our speaker. Thank you.
Thank you. There it is. So thank you a lot for having me here. I'm Lars Bendix. I'm administrating a network of people that are passionate about software configuration management. And then I am also at Lund University, where I teach a course on software configuration management. And actually that course on software configuration management is the main reason why I'm here today. Because on that course, the student, they have to do a small project. And lately, quite a few of the groups, they have chosen a project about how to introduce software configuration management into a young agile startup. And if they had gotten it right, probably I wouldn't be here today. So let's dig into it. So the premise is that software configuration management or configuration management activities should be carried out on all projects. Otherwise, we'll have chaos and anarchy. If there's chaos and anarchy on some software development projects that have software configuration management, then that has different reasons, and that's another story. However, on many projects, the operational part of software configuration management is carried out by people that has absolutely no software configuration management background. Maybe they have heard a little bit about Git, but there's a lot more to software configuration management. And that means that they have no tools in their software configuration management toolbox. When they have no tools, they are maybe not doing the operational part of the software configuration management in the right way. Maybe they're not doing it the best way. They have absolutely no idea sometimes of why they're doing things. Sometimes students, they come to me and say, well, I work in a company and we do something, and people tell me that from time to time I should do a Git rebase. And I have absolutely no idea why and when, but sometimes I do it and sometimes I fuck up things. So if you do it, you should have some idea of what it is that you're doing. If you know what you're doing and why you're doing it, and know a little bit about the concepts and principles of software configuration management, doing the operational work from time to time, most of the time, you have to follow the rules. Trust me. But from time to time, you have to do an exception. And sometimes you have to twist the rules a little bit and adapt them to your context. If you don't know why you're doing stuff, and if you don't know a little bit about the concept and principles behind, then it'll be very difficult for you to adapt and to know when to make an exception. That is why in all projects, in all contexts, in all companies, we need a certain amount of strategic software configuration management. For instance, like a person that has taken my course on software configuration management, or that has had some practice of software configuration management in another company and knows something about it, and can sort of design the overall processes, the way that people should be working. And now that we have these people, then we can sort of educate the people and have the operational software configuration management carried out in a more consistent way. The purpose with the presentation today is to try to convince you or show you that any company, even something as small as an agile startup, a lean, without any resources, without any formality, will have to have configuration management. It's critical for their survival and it's critical for their success. A startup also has the advantage that it covers everything wall to wall. So everything from what the developer has to do when they're working on the project, over the coordination of all these people in a team, from the company that gets products from the teams and have to sell them to the customers. So it's sort of wall to wall. Now the setup that I give the student is this company, 4 Freaky Friends, 3F. 4 friends, they're just about to graduate from Lund University, and they're living 24/7 in a borrowed garage. They're hiring you to help them out with the software configuration management. Since it's a young agile startup, they don't have any money, but you can get 10% of the company. And that should also sort of encourage you to do a good job, because otherwise, if they fail, you'll get 10% of nothing. There's a lot of uncertainty. They're changing goals. They have some vague ideas. They have a lot of ideas. And now they're about to start, and they want to get going. So let's see how we can help them and get 10% of a huge amount of money, the value of this company. So the first task that we get is to make sure that this startup actually survives the first couple of weeks, the first couple of months. And to introduce software configuration management in this company, it should be carried out step by step. So they don't have time to take my course. It takes 7 weeks. It's too much. They have a lot of other things to do. So we should prioritize what is the most important, what is the first thing that we should introduce, what is the next thing, and then sort of step by step introduce these concepts and principles from software configuration management. Having no money, they couldn't even pay you. We have to do it in a cost-efficient way. So not a lot of red tape and bureaucracy, not a lot of fancy and expensive tools, but just enough to make them survive, maybe earn some money, have some money that they can invest in more and better software configuration management. The operational part, the day-to-day work with software configuration management, has to be carried out by the developers. You get 10% of the company. If it's a success, that'll be a lot of money, but you don't have the time nor the interest to be there 40 hours a week or 24/7 like these guys, they're working. So we want to educate these people a little bit more than just train the monkey to do as it is told. We should educate them a little bit so they know why they're doing things and they know a little bit about the concepts, but a little bit more than just what they need to do the job. And then you, the strategic SCM person, you have to design the processes the way they should be working, explaining them why they should be doing this, and then you're done. So for software configuration management, what is it that we need to introduce them? Why should they do this? When is it that it should be introduced? And how is it that they should do it? The how I will not dig very much into today. I mean, my course is 200 hours, and I got 45 minutes today, so I can't more than touch on that. Now, the first attempt from my students usually is something like, we should teach them Git, how to use Git, and then we should dig into branching, and something about distributed development, and blah, 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 and more. And I said, well, wait a minute. I told you that these guys, they are staying 24/7 in a garage. They're not distributed. I mean, they might be in different corners of the garage, but I mean, the garage has a certain size. Branching, we adopt the KISS principle. Keep it simple, stupid. Let's make sure that they survive. And then maybe sometime in the future, we can tell them about branching, the wonderful thing that's called branching. Git? Well, probably that's a little bit my fault, that I didn't make it exactly clear for my students, or maybe they didn't read the text for describing the project proposal, that these guys have not started yet. They have some vague ideas. They have a lot of vague ideas, but they haven't written a single line of code. So yeah, I can tell them about how to use Git, but they don't have anything to put into Git. So it's sort of kind of useless right now. Yeah, why not Git and branching? Well, I've already explained that. So software configuration management, I also asked some practitioners in the network and got some input from them. And they said, well, teach them about how they can tag the source files, or how they should identify configuration items, something about the tools that they can use for software configuration management, a registry of configuration items, collaboration tool to share things, and change control. It's not sort of really exactly what I'm looking for. I think that these practitioners, they are far removed from a startup. They have their day-to-day work, and probably this is a list of what they wish they could introduce in the company where they're doing configuration management. During the exam, when we talk about the project, and when I have excluded distributed development, I've excluded branching and Git, then I tell my students, then what could it be that I'm looking for? And I can sort of see the desperation in their face, and then they come up with, is it Wayne Babbage? Because they know that, for me, Wayne Babbage is God. So Wayne Babbage identified 3 fundamental problems of collaboration, of team coordination: the shared data problem, the double maintenance problem, and the simultaneous update problem. And I don't miss a single opportunity during the course to mention Babbage. And I said, I'm sorry, but it's still too soon. We'll definitely introduce them to Wayne Babbage later on, but it's something else that I'm looking for. And usually after a little while, the students come up with, is it Daniels? Daniels is the author of a book about traditional configuration management with the 4 traditional activities. And the way that he describes it is how to do software configuration management on a huge military project. It doesn't get any worse than that. And most of the time, the students, they hate it. And I say, yeah, it's the most formal and bureaucratic part of traditional configuration management. That is the first thing that we should introduce in this Agile startup. Configuration control, the activity of configuration control. also known as change management. Actually, in the standards, they're sort of changing it from configuration control over to change management. And I hate that, because I've got hundreds of slides where it says configuration control, and now I have to go through all them one by one and change it to change management. It's a pain. So why is configuration control, change management, the first thing that a young agile startup should pick up on? Well, let's look at it. What is it that this agile startup has? Hopefully, they have 1 million ideas. Otherwise, they don't have a startup. Later on, they'll get a business consultant and they'll get a legal advisor or something like that. But if they don't have 1 million ideas, they don't go nowhere. What is it that they don't have? They don't have time and resources. So what is it that they need with 1 million ideas and no time and resources? They need to prioritize and focus on what is the most important and valuable thing to work on now. That's the core of software configuration management. That's what we can help them with. Ways of prioritizing. What is it that we should work on now? What is it that we should work on later? What is it that we shouldn't work on at all? That is configuration control, that is change management. So now that we have explained to them that we can help you prioritizing and focusing on what you should work on, then they should be motivated for listening to how to do change requests, how you can document the changes that you want to have, how we can have a change control board, a CCB, that will prioritize all the changes that we have, and also a change control process that sort of can define a process, a way that we can handle these change requests. If we dig a little bit into the how-to of this, what is a change request? How do I make a change request? I also, besides Wayne Babbage, I also tell my students that most of the answers to questions about software configuration management start with "it depends on." Is it a small agile startup? Is it a huge company that does software, control software for nuclear power plants? Is it life support machines? Is it a game? Whatever. The concepts and principles are the same, but when we implement them, we have to adapt them to the context. So a change request in this agile startup could be something as simple as a yellow post-it. You get an idea, you write it down on the post-it, and you put it on the whiteboard. You get an idea, you write it down, you put it on the whiteboard. Maybe at a certain point, you get a bright idea, and you find that there's not room enough on a yellow post-it, and you find an index card that is slightly larger, and you write it down there, and you put it on the whiteboard. That could be the first step. We need to document what it is. Then maybe at a certain point, we find out that when we're discussing an idea, or when you're looking at an idea, who came up with this idea? Because I need more information about this. And then we find out that, well, maybe we need another field on the yellow post-it, the name of who came up with this proposal. And as we go on, we can sort of add more things to this. But in the beginning, anything as simple as a yellow post-it and an index card would be sufficient for this agile startup. The change process, well, we've already been through the first step, documenting what it is that we want to change. If you find a bug, you just document that there is a bug, where it is, and what you carried out to make the bug come out. And that's a change request. Someone needs to fix it. Then we should filter. Maybe more of you come up with the same bright idea. Maybe more of you discover a bug. And we don't want to treat the same change request several times. So we need to sort of group them and say, well, this is basically the same. Analyze what is the impact. what needs to be done as a consequence of this change request, and estimate how much will it cost in time and resources. Once that we have all that information, we make a decision. Is it something that we should do? Should we do it now? Should we do it later? Or is it something that's not worth it? And then we can sort of follow up. If it's something that's not worth it, we'll ditch it. And if it's something that should be carried out and implemented, then we have to follow up. Did you implement it? Did you test it? Did you integrate it? Is it done? Is it ready? Can we move on to something else? And so on. The Change Control Board is nothing but a decision machine. You feed change requests into the decision machine. These change requests should have perfect information. Once we have perfect information inside this decision machine, we have a person or a group of people who will make a decision. If the information is perfect, hopefully, they will also make a perfect decision. And they will sort of divide it up in, this is what we should do in the next sprint. The next 2 weeks, we should focus on this, because this is the amount of work that we can handle in the next 2 weeks. And then in 2 weeks' time, we'll do another meeting, and then we'll see what we'll work on the coming 2 weeks. Tools. Well, if you're not happy with the yellow Post-its and a whiteboard, then you can sort of pick up on tools. And the concepts of planning game and backlog grooming is nothing but sort of a CCB meeting where you handle change requests. Survival, what's the next step? Now that we have taught them about change request and change management and CCB and stuff like that, what's the next thing? Asking my network of software configuration management practitioners, they come up with, well, we need to have something about processes after the CCB. They need to be taught how to work with Jira and Kanban and the minimal workflow, definition of done or definition of ready. They need to be explained where to put the source code, how to deliver, how to develop, traceability. Again, for most of these things, they're sort of a couple of steps ahead. In my opinion, the next step that we have to introduce is still in line with Daniel's, the traditional configuration management. So we need to talk to them about configuration items. We need to tell them there's a lot of stuff in a project, a lot of things, and instead of having to say emails and documents and source code and test cases and requirements and blah, 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 we use the generic term artifacts. So we have a lot of artifacts on a project. Some of these artifacts are more important than others. And this subset of the artifacts, they will become configuration items. And when they become configuration items, they are under the protecting wings of the configuration manager, and they will be managed. There will be a little bit of overhead, but it's worth the value that we get from protecting them. So important things must not be lost. The ideas that we get, what will happen if we leave the garage for a couple of hours and one of these guys' mother comes in and she wants to clean up the room, and when we come back, the whiteboard is completely white. Where are all our bright ideas? Can we come up with them again? What happens if suddenly your source code is not there anymore? What about your test cases? Well, you can recreate the test cases from the requirements, but it'll be a lot of work. If they are configuration items, even if you erase or commit something, then we can find a way of bringing it back, if it is a configuration item. If it's not a configuration item, we can hope that it's on a backup or whatever. Exactly what will be a configuration item and what will not is sort of, there's a blurred line. If it is important for you, if you will cry if it disappears, then maybe you should turn it into a configuration item. A configuration file that will make your application run looks like it's important. Let's make it into a configuration item. So as I told, to a certain degree, it depends what will be a configuration item and what will not be a configuration item. Sometimes the students, they take the easy way when I ask them what will become configuration items at the exam and say, well, all the artifacts. And say, we don't have time and resources for handling. Because if something becomes a configuration item, you will, as a configuration manager and also as a developer, will have to spend a little extra time when you work with that. And sometimes you don't want to do that. Sometimes you just get a note from someone and you read it and you implement a little bit and then you just throw it away. No hassle about that, no red tape, no bureaucracy. One thing that is highly dependent and that we need to talk to these guys about is the metadata. Not just the configuration items, not just the source code, not just the versions of the source code, but also data, information that we can connect to this. So for instance, who implemented this? I need to fix a bug here. Who implemented this code? Who implemented this feature? Because there's some of the code that I don't quite understand. So you did. Okay, I need to go and talk to you. Let's have a coffee. Let's go and discuss this. Why was it implemented? Was it a feature, a bug fix? Oh, it was fixing bug number 12. Okay, I can probably go into another system and find a description of what bug number 12 was, and I can get more information about it. But if this metadata, if this information is not there, then we're sort of blind, and it's difficult to work. What commit a task was implemented in, such that we can go back and forth between the issue handling, the task system, and the commits that we have in Git or whatever. Connected to the configuration items in the traditional configuration management, we talk about a configuration management database. Mostly in small agile projects, this configuration management database is Git. Since it should be a database, and since we need to have metadata, since we would like very much to have traceability to be able to go from one piece of data to another, we should also have something like relations. And quite honestly, Git sucks as a database, because Git was never intended to be a database. Git is a collaboration tool, and it's wonderful as a collaboration tool. So at a certain point, we might want to create a sort of heterogeneous environment with different tools that will sort of together make up our configuration management database. Now, we have managed to make this young agile startup survive at least the first week. Now we told them about how to focus their work, prioritize their work. We have told them that there are certain things that you must make sure that they don't disappear and that changes to them are controlled. So now we want them to be successful. Now we want them to get to the market. So let the work begin. Now we have decided what we should work on for the coming 2 weeks or for the coming week. Now they can start coding. And we want to turn them into a lean and mean delivery machine. They need to collaborate now. They must prove themselves. They must prove themselves fast and often. And they must have a trustable quality. Trustable quality means that it probably shouldn't be like Swedish perfect, but neither should it be Danish sloppy. So it should be sort of, yeah, you know. Now, what is the next step after change management and configuration items? My friends in the software configuration management community, they say delivery, release, fast, quality, something about Git, keep the backlog clean. Well, we are sort of almost there now. Now is the time to introduce Wayne Babbage. In the mid-80s, he wrote a book about software configuration management for team coordination, where he was sort of identifying and describing the problems that a team has in coordinating its collaboration, the different contributions that they have. And he identified these 3 problems: shared data, double maintenance, and simultaneous update. They were there in the mid-80s when Wayne Babbage discovered them and described them. I see them still today. When I'm dead and gone, they will still be here. We cannot eliminate them. And I give examples to the students of even me working alone will be able to create shared data problems, double maintenance problem, and also simultaneous update problems. Mostly we have to deal with shared data and the double maintenance. Most of the time, the version control tool that we are using will take care of the simultaneous update problem and protect us from that. There will be a couple of cases where we, by doing something very stupid with the version control tool, will be able to create a simultaneous update problem. But now that they have to program, now that they have to collaborate and work together, once that we have explained them the theory about the problems, so they will be able to say, oh, I think we have a double maintenance problem here. Then if you can identify the problem, then you're halfway to the solution of how to manage the problem. Now we will explain them something about collaboration tools, how they can use these collaboration tools, Perforce, Git, ClearCase, if anyone is still using ClearCase. And to handle these problems, we need to tell them about the repository and the workspace. In some cases, you get sort of a flat workspace. In other cases, you get sort of a local repository with a workspace. And sometimes it's difficult for them to understand what it is that they're working on and what it is that is where and so. And we need to tell them about continuous integration, why they should do continuous integration, when they should do it, and why they should do it. We need to keep this thing together. Wayne Babbitt's double maintenance problem says that when you have a workspace and you work on the code, you have a workspace and you work on the code, you have a workspace and you work on the code, and I'm the 4th developer, I have a workspace. We have copies, but they will grow apart. And the longer time they grow apart, the more difficult it'll be to get them together. And continuous integration is nothing but a desperate attempt to, as often as possible, to synchronize the different workspaces that we have on the project. But we shouldn't become too disparate. So we shouldn't randomly say, now I want to synchronize, now I want to update, now I want to see what everyone else has produced. If I'm in a mess, my code doesn't compile. Since it doesn't compile, it doesn't even test. And now I take in your changes and your changes. It still doesn't compile, it still doesn't test. I'm still in the middle of chaos. And I'm not any wiser. And probably I also closed my eyes when I did the pull or the update, so I didn't even see the information of what the tool did to my workspace. So we could tell them, open your eyes and see what the tool does to your workspace. And only do these things when you're in a good, stable state. When my code compiles, when my code runs all the tests that it should run, I want to take in your bug fix. Now it compiles, but there are a couple of tests that it doesn't pass. Well, it's not your fault. It's not my fault. It must be something between my feature and your bug fix that doesn't quite work. But I know that because my feature worked, and I hope that your bug fix worked when you pushed that. Now we need to look into that. That's a lot easier than it is that I'm in a mess and now I'm still in a mess. Git commands, they need to learn a little bit of Git commands. 3 commands: git commit, git pull, git push. That's it. No branching, no nothing. Just commit, 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 pull, push. and no options on the Git push. I have threatened to fail students if they mention a certain option on Git push. I don't want to hear about that. Then I want to tell them something about continuous delivery pipelines, about quality gates. And please note that I put some quotes around delivery. Why did I do that? Because delivery, as I see it, can be to a lot of different targets. In this context, right now, I don't want to deliver to the customer or to end users. I want to deliver to my team. It's still a delivery. It still should be treated in a serious way, and it should be a quality gate. We, as software configuration managers, we are the masters of quality gates. We can give you any quality gate you want. You decide what should be the quality gate. On some of our student projects, the first quality gate that they have is, I made some changes, that's enough. And then they push that. Then they figure out that, well, maybe we should have a quality gate that says that it should also compile. And that will be the next level. And then at a certain point, they say, well, it should run the unit test, some of the integration tests, and so on. They find a sweet spot for where this should be. And again, it depends a lot from company to company and what you're doing, how high the quality gate. I might have a personal opinion, but professionally, I don't care. If it's sufficient for you that the code compiles, I'll implement a continuous delivery pipeline, a quality gate that will make sure that if it doesn't compile, then your push doesn't go through. I might then go to the project manager and tell the project manager, we can do better than that. Would you let me do that? Then I'll also run all the unit tests, and if it doesn't pass the unit test, then it aborts the push. I want to show you a slide. Probably one of the most important things that you have to teach and explain to these people is that you should keep the repository clean. It's not sufficient that you have changed something. It's not sufficient that the code compiles or that the unit test runs. We should also sort of run the integration test. It is actually a delivery. We delivered it to the team, and we should be proud about it, and we should take it serious. And most of the time I show this slide to the students. And actually, like 5 or 6 years ago at a conference in Italy, during a break, I was approached by a young man, and he said, "Do you remember me?" And I looked at him and said, "No, not quite." I said, "Well, when you were here in Parma 10 years ago, giving a small course on software configuration management, I was following that course. And still to this day, I remember this slide with the shit that was hitting the fan, and it was spreading all over. And I like this, because it means that this is a visual picture that really goes through and explains, and hopefully they understand that this shit is your code that hasn't been tested. And when it hits the repository, in a fraction of a second, someone will do a pull, someone else will do a pull, and someone else will do a pull, and now we have shit all over the place. And that's the worst possible situation that you can have. Explained in this way, a young student remembered it 10 years later. This young startup, they don't have to remember it 10 years after, so they'll probably get a couple of practical lessons on the way. Now, the next task is to bring a little bit of maturity into this startup, to make sure that they stay in the market, that they outperform the competitors, that we keep our investors happy, that we make our customers happy, and that will generate some revenue and get some money, and then I don't know what else they could wish for. Now, for maturity, then now I remove the quotes of delivery. Now we really have to be serious about continuously being able to put out something, to prove ourselves, to make the changes go out there, to start making revenue in some way. We need to earn money on this. And whether we deliver or we deploy depends a little bit on the context and the application and that we're doing. I was a little bit ahead on my slides. So we need feedback. The reason for continuous delivery, this continuous deployment, is that we need to have some feedback. More feedback than the code compiles and it tests. What do the users like? What is it that they use? Does the market like our ideas? Years ago, an ex-student of mine gave a small presentation, and he had been working at Atlassian, and he said in one of their tools they were sort of testing out, and they wanted to experiment with whether software developers in a development tool, if they would like to be able to order pizza directly from the development tool. So they put a small button that said order pizza, and if you push the button, it would say, sorry, it hasn't been implemented yet, come back later. And in 1 month, about 12 people pushed the button, and they thought, well, maybe it's not worth the effort to really implement this stuff. But if you don't have something like continuous delivery, continuous deployment, then you just have your ideas, and maybe people, they don't like it. And we need revenue. The more we can earn. When we become a little bit more mature, it is also time to start looking at something like branching strategies. Again, very simple. If we sell our product, we probably will also be asked to maintain it. And we should be able to create a maintenance branch and how we should handle a maintenance branch. Even if we have continuous delivery, continuous deployment, sometimes we have to cut a corner to make it continuous and fast, which means that it's not perfect. That's sometimes the reason why we have a maintenance branch. That is sort of to fix the things that we didn't discover in the quick testing in the continuous delivery. But sometimes we say, well, for most of it, at least for what regards the team, we are happy with continuous delivery and it works perfectly. But when it's time to do a release, then we don't want to release what we have delivered to the team. We want to fix the final small issues. And we could create a release branch and have a couple of people work on fixing these small issues. When they're done, we do the release, and then we convert it back into the development line. And then the rest of the team can continue and implement things that can generate revenue. The takeaways. So the main points today is that when you go home, if you are DevOps, belong to the DevOps part of the audience, then look over your company and try to see if how your change management handling is. Does it need to be polished up? Is there anything at all? Probably there is something, and most probably it could also be fine-tuned and improved. Configuration items. Probably most of the important things are configuration items. From time to time, I still get goosebumps when I hear about young, agile DevOps companies that sort of dynamically link in external libraries that they're using. And I tell them, you must be kidding. You can't be serious. You're basing the whole future of your company on the fact that this external library will still be there tomorrow and that no one else has touched it and changed it. Have you ever heard the famous phrase, "It works on my computer"? I can see that at least a couple of you have heard this expression. Why does it work on your computer but not on mine? Because when you linked in and compiled the system, version 7 of the external library was out there. But half an hour later, when I compiled the system, it was version 8 of the library that was out there. And I have absolutely no clue that they have changed that. We can work for days and maybe even weeks before we discover that actually it was the external library that changed without our control. It scares the hell out of me. If I need to use that library, I will download it, I will turn it into a configuration item, and then we use that. When you discover that there's a new version with more functionality, I'll say, file a change request. Then I will have someone go and look at that, verify that it's still good and sane, verify that we can use the things. I will download that and put it in as a new version. At a certain point, the project will decide that from next Monday, we will upgrade and everyone will use the new version. Orderly development, a little bit of common sense. Wayne Babbage, collaboration. Git is not a version control tool. Usually we never look back. If we look back, maybe we look back at a release that we tagged, but usually we are trying to manage, in particular, the shared data and the double maintenance problem of Wayne Babbage. Git works wonderfully if we try to use it the right way. Quality gates, shit should not hit the fan, so try to because if you do a poll, then you'll get the shit. And you'll get it, and you'll get it. And the worst possible situation that we can have is the one that we have sometimes with our students, is that once you discover that there's a problem, you start working on fixing the problem. And he does the same, and he does the same, and you can sort of imagine what will be the mess. So when that happens for our students, when they come around lunchtime and discover what is going on, they sort of say, this doesn't look good. Let's see if we can return to how the state was this morning, and then just scrap what we've been doing this whole morning. And that's not very pleasant. And then continuous delivery. What do you think is the toughest task when introducing software configuration management to a young agile startup or to a company? Sorry? My impression is that small and medium enterprises, they are convinced that software configuration management is very bureaucratic. It's extremely difficult, it's very costly, and it slows down development. That is fake news. That's so fake news. It's not bureaucratic at all. I can't see anything bureaucratic about yellow post-its on a whiteboard with people's name on it if we want to add a little bit more information. It's not difficult. I mean, commit, pull, push. It's not difficult. Forget about rebase, forget about branching, and forget about the special option for a push. We don't need that. Costly, Git is for free. Post-its don't cost very much. A whiteboard, probably you have something in the garage. Slows down development. Yes, a little bit, a fraction. But if you have, like, the shit hits the fan, the shit hits the repository, it'll slow down development a lot. Not just slow down development, it will stop development for a certain period. And that can be more costly. Or you and me trying to figure out why it works on my computer, but it doesn't work on your computer, and it's because of different version of an external library that we don't have under control. A lot of time wasted. Whereas a little bit of work invested in this configuration management will help you a lot. Further reading, if you want to dig deeper into these things, you can join our snesm.org network. If you want to dig into the software configuration management things, we have configuration management coffee meetings from time to time, and a yearly software configuration management day where we discuss these things. If you're into sort of the startup part of this, I advise you to go to Dave Farley's YouTube channel. He's done a YouTube video, and a very well done video, where he doesn't focus on software configuration management, but he focuses on the software engineering aspects. So the coding aspects, the architecture aspects, and how you handle all these things. And that could be very useful if you're a startup, and probably also if you're a company. That was sort of the final. Well, I have one or two more slides, but they are not part of the presentation. They're just there as placeholders. So, any questions?
You were just way too clear in your message.
Or maybe people, they're just hungry for pizza.
Thank you for the presentation. How would you convince them that they have to use software configuration management? Okay, you can tell them that it's fake news. But I guess you want to provide some data, like data supporting that.
This presentation is being taped, so maybe I shouldn't say this. But apparently it seems that a lot of Americans, they are fact resistant since they elected Trump. And there will be a lot of companies, a lot of developers that are also fact resistant. But if you can, I hope that telling them about, we can help you to focus your efforts on the most important things. If you do a little bit of work, that can convince them. I hope that with Git and Wayne Babbitt's 3 coordination problems and the continuous integration and how you should collaborate and coordinate this, maybe they say, well, you're just like my father, and I know better than you. Maybe my father cannot do that, but I can. I can walk on water. And my approach to that is that, okay, go ahead. I told you, I warned you, I showed you the picture about shit hitting the fan. When you get into a situation where shit really hits the fan, then maybe you'll come back to me and say, was there any more that you wanted to tell me? There are some data out there, fairly old data, that shows that an investment in software configuration management repays in, that was introduction of ClearCase. Anyone know ClearCase? Have you worked with ClearCase? It's about the most heavy and difficult to use version control tool, configuration management tool. And even an investment in that, paying a lot of money for licenses, paying for educating people in this, paid back in 7 months. They found a lot more bugs. They spent more time on implementing features and less time on fixing bugs. They spent a lot less time on building systems and trying to figure out what it is that we have. So there is a little bit of data, but if people are sort of data resistant, then tell them a little bit about if you do like that, then you'll end up in that situation. And if they don't listen to you when they finally end up in that situation, in that mess, then maybe they'll come to you. Or maybe you should find a different company to work for. There's one more.
When I was going to this talk, I didn't expect that would be software configuration management will be about the whole process. And I think many of the things you covered, it's kind of common sense software development for many people. Like if you just buy in with what's used in the industry, like Git, you use Jira, Trello, or whatever to track between what is kind of common sense of modern software development and full-on CI/CD, where we actually tracking the whole thing. And I think configuration management, this covers everything, but for buy-in, like if you're talking about agile startups or just any company who starts, I don't think we need to sell them start to say about configuration management. So how do we bridge this gap that, yeah, maybe you're using Git and you're doing this agile kind of, because sometimes it's more of a cargo cult, but still you're trying good, but there's behind this the whole kind of science and everything. So do you have a suggestion, like people who are already doing many of the right things, but to keep them on track, or at least set them a goal, like where do they need to be, or so they just not trying just to repeat things they heard somewhere around?
Well, you're completely right that, like I said, software configuration management is not difficult. It's not rocket science. A lot of it, at least when you know it, is just like common sense. And that's why sometimes I don't understand why people, they don't practice it more. But there's a difference between applying common sense and then knowing the concepts and principles that are behind, and knowing why you're doing certain things, and when you could sort of adapt or make an exception, and when you should not make an exception for it. I think that what people should try to do is that they should try to continuously improve on this. So if you're doing something like Agile, DevOps, or whatever people they call it these days, if you work in sprints, if you're using Scrum, you have something that's called retrospective. So every once in a while, maybe after each sprint or after 2 or 3 sprints, you have half a day off, and then you look back on how are things going. Where is it that we seem to have problems? What is it that is causing pain? And how can we address that? Sometimes it'll be a configuration management issue. And other times it'll be maybe an architecture issue, a testing issue, or whatever. And then spend a little time on looking into not just what Git commands should I use to obtain this. And then forget about all the dirty things in Git. You don't need them.
Good. Thank you so much, Lars. That was fantastic, and yeah, I think more than young agile startups can learn from it. I think we can conclude the presentation part for now and move to the other room. Thank you.
So.